So hello guys, Ganesh here. Welcome back to my YouTube channel .twg. So coming back to our discussion. So last video we have seen about what is class A, class B, class C surfaces clearly, right? So in this video we will try to know. We will try to know what is a class A, class B, class C in a software, right? So this is a sheet metal bracket I have with me. Okay. So let's say for example, okay. So from this side you will be it will be appearing outside, right? So that means you should be having a good surface finish, and it will getting the impression at very first day. So what I can say, this will be my class A surface. So let's take one tool, extract with the tangent continuity. Okay, we can see a surface is selected, right? Okay, so this is all surface, so which is appearing from the outside and which is influencing the aestheticness of the part. So that's why we can call it as class A surface. Okay, and in the bottom side you can see the surface. Okay, so this is what I can say class B. So right now it is not having any features, right? So for example, it is for some purpose it has to be going to mounting with other part, right? So right now I not developed all this thing. So the class A should always possess of having that engineering features. Okay, so now let's take about the class C. I told you that the surface that connects the class A with class B is a class C surface, right? So here you can see what is class C. Here I'm having a little issue. Okay, double click on this part. I think bidirectional. Preview. Okay. Okay, now it has got updated. Okay, so this is fine. Now with the class C, what you can say, I can take the multiple extract command. Okay, I can use the point continuity this time and select this. Sorry, you cannot do like that, because when you're taking the point continuity, if you're selecting this, so whatever the things that are when you point contact with this surface will all will be selected. But when you're taking the tangent continuity, so like similarly what we have done in the earlier steps, so I selected only this surface, so which are having the tangent continuity with this face, that all are connected, right? So that is the use of the continuity factor. And let's take about multiple extract, and this time we shouldn't use any continuity. Okay, we have to select the C surface manually. So don't worry about these tools. We will be seeing everything regarding the software from the basic level onwards. I forgot a face here. And then his face. Okay, I think the class A all are selected. Cancel. Okay. Now after this, what I can say, I will hide it for you. Okay. I will hide the part body. So there is no part body in this. Now we are having the surfaces only. So class A. So this is the class A. Rename it as a class A. Enter. And I can remove it as class B. Enter. And I can rename it as class C. Enter. See. So let's hide these two. Okay. So this is how the thing will look like when class A is given to you. So out of this you have to develop a part body. Okay, so I will show you the basic process. Okay, so that you can understand how the tools will use. So of course this is not a complete video on surface design tools, so we will be seeing every single tool in the upcoming sessions. So this video is just you knowing you what is class A and how the process approach will work out. See, I got class A surface. Okay, now we will do the part body by our plastic product design process. Okay, so what I do, I'm just taking the offset. Okay, but before that let's hide the class here also. Let's unhide the part body. Let's measure the thickness. So select this tool and make sure this one, select this surface and this surface. See, minimum distance is 2 mm. That means our thickness is 2 mm. Let's hide this body and hide the class here. Let's make a one offset up to 2 mm. Select this face. So 2 mm is offset. Preview. Okay, it is going downward direction. That is what I want also. Click on OK. Okay. So now I have class B surface. Okay. So next step will be here you have to see the manufacturing constraint also. So what is the manufacturing constraint? See, for example, this is a mold. Okay, so when you are doing it mold, a plastic some quantity of mold and plastic material will be stored in this cavity, right? Okay, in order to fill the mold and plastic material in this cavity. Okay, what you have to do, you have to specify a tooling direction, right? So right now if you want you can specify the tooling direction. Okay, right now I'm not specifying it now. So next video you will be seeing a complete tutorial about the tooling axis and how the part will be manufactured and how the part has to be done or modeled with regards to manufacturing constraints. Okay, I'll just show you. So there is a command called boundary. So boundary, set the first surface. So what does this tool will done? It will extract all the outermost edges of the selected surface. Okay, now I have one boundary. So similarly I need to have the class B boundary also. Next step, what I do, I just join these two. So what is the tool for that? You can use the blend tool or the multi-section tool. For sake of understanding, I'm using the blend tool now. Select this curve and this curve and make sure the directions. So we'll be saying more about this blend and multi-section tools in depthly in the upcoming videos. So right now let it be like this. Click on OK. See, you can hide these curvatures later. See, now See, I have one more problem here. Click on the blend, and here there is a option called the couplings. Okay, okay, okay. Blend tool. You can delete it. We use what it is, multi-section solid. So select that. These two perform the same operations. Okay, select this. Click on preview. See, this point is not coinciding with coupling with this point, right? So in order to change that, set this point and this point, preview. Now it is going correct, right? Similarly we have to done here also. So or else you can directly vertices, preview. Yeah, so this is fine, right? So you can hide the sketches or curves. So this is about the class A, class B, class C. So now we have three different surfaces. Okay, so when you are using the boundary feature, so you can see, even see for example, if it is a 3D body, see here we having some gaps. Okay, in this case, if you example, if you're pouring a water in this, so pouring a plastic resin inside this closed chamber. So if you pour a plastic material inside this chamber, what will happen? If you have the openings, it will be flow out, right? So that is the thing that we shouldn't have. Okay, here we have three different surfaces. So class A, class B, and class C. Three are like three domains. So not each and everything is connected with each other. So in order to combine them together, we can use the join feature. So join, select the A surface, select the C surface, select the B surface, preview. And the join feature, what it will does, it will combines the selected surface as a single surface. And also what it is does, you can see the gaps here, right? Initially you have seen a gaps here, but after joining you won't see any gaps. So that is a thing that you can see here, merging distance. So whatever the things that are under the 0.001 distance, those are covered. Okay, for example, okay, under this. Okay, so imagine there is a gap more than that value, so those are cannot be joined by join tool. So in that case, what you do, you increase this value, it can accept up to 0.1. Okay, so that's it guys. So if you want to use the part feature for this geometry, what you have to do, you have to always check the boundary feature. So if it is showing this error, which means, so whenever you whenever you taking the part body, so it is not having any 2D geometry, right? So the concept is very simple. Okay, now let's use the go to part design workbench. Okay, let's use the close surface option. Okay, it is asking to select one more body, insert body. So okay, body 2 is added. Okay, let's use the close body for this feature. Click on OK. Now you can join this. Wait, what does it happen? Part body, select the close body, close surface, select this, click on OK. So yeah, I have the surface now. So yeah, you can see that, right? So I'll just translate it to a little. So translation option, select this book and choose the point coordinates. Okay, let's increase this value. Let's take 100. Okay. Okay, let's unhide the previous body also. So let's increase this translation to 200. Okay, now you can see this is a part which is given by which is given earlier, and this is a part we designed it, right? So this is how the surface design surface modeling will works. And since it is a very simple part, it takes only less than 10 minutes for us, but it is also having the similar planar faces, so that the design process is very simple. But when you see about automotive industry, the most of the parts are not planar face surfaces. They are having the most complex surface curvatures, right? So so in the upcoming videos, we'll be seeing how we can be model those things. So in this video, we'll be ending up to this. So we'll be seeing in the next video. Thanks for watching. Have a good day.